Hi everyone. I hope you all are doing great, right? So let's start the session, right? So today's session is going to be very interesting because I'm going to just discuss about the one of the famous routing protocol that is a BGP, right? So you might guys all aware about, right? We having a different routing protocols, but one of the key protocols, right, is still everywhere it is using when you talk about the any routing scenario. When you are discussing about the pure routing and switching, then it is going to be required. When you discuss about the any firewall routing concept, next generation firewall routing concept, right? Likewise the Palo Alto, FortiGate, Checkpoint, they all capable to understand the BGP routing protocols, and they are able to carry the BGP routing tables, and it's very quite popular everywhere it is going to be used. And if, even you are talking about the next gen, you know, technology like the SD-WAN, we are discussing about every SD-WAN. You can discuss about the Cisco SD-WAN, right? You can discuss about the any Silver Peak, right? You can discuss about the any Velo Cloud, right? You can discuss about the Versa, right? Any FortiGate SD-WAN. Everywhere you can find either it's acting as the overlay, as a routing protocol, as a MPBGP, or might be it is going to work as an underlay, as a pure BGP, right? So these overlay and underlay, it's everywhere is going to be used. That is a BGP. So it's very common, right? Even someone is thinking I am the SD-WAN engineer, right? And I don't need to understand about the BGP. It's totally, I can say not true. You should have the basic understanding with the BGP, right? Because why basic understanding? If you don't know the BGP, then if you are just building the fabric about the Cisco SD-WAN, right? And there is underlay connectivity, and in this underlay connectivity, right, you require to run the BGP. Then how you are going to run the BGP? Might be a circuit went down, right? Might be something which is connected to ISP, which is just going to give the basic IPv4 reachability, and that goes down. Then how it is possible, right? So everywhere BGP is very important, right? So we're having the different lab topologies, which I'm going to discuss in the later stage, because we having the very advanced level of the labs regarding the BGP, MPLS, right? So I'm not going to discuss everything right now, but I'm just going to discuss the fundamentals about the BGP, right? How the routing is going to be happen, right? And what is the key concept? Why we need the BGP, right? And why basically we cannot use the IGP everywhere? Most of this kind of the question is going to ask during the interviews, and people are always confused, right? So I'll try to explain each and everything. What was the need and what was the drawback of the IGP protocols, and because of that, this BGP come in a picture, right? So we having the very robust lab topology, which we keep discussing in the routing, advanced routing, when we talk about the CCNP, NRC, and even the CCIE. So we having the MPLS, we having the inter-AS communication between the different areas. We having the EIGRP labs, we having the MPBGP lab, static routing everywhere, right? So that is going to be, give the inside depth knowledge about the BGP when you are just going to discuss about the multiple scenario, right? And in multiple scenario, it's just not a BGP. In multiple scenario, you must have the understanding about the MPBGP, which is the part of the MPLS, right? So these are the core and these are the basics. Even you can become the very advanced network engineer, and you are working as a L3, L4 in different organizations. You are saying I'm the SD-WAN expert. I know the triple SD-WAN. I know the fourth SD-WAN. But if you have not basic fundamental of the routings, you might be a struggle. And this is the true reality. That's why I'm just here to discuss about it. So let's talk about the basic fundamental about the BGP. What is a BGP? So first, when you talk about the BGP, so BGP is just, broader gateway protocol. So it is known as, let me write here. So it's a border gateway protocol. This is known as the BGP. But why it's a border gateway routing protocol, right? So basically, before this border gateway routing protocol, we having the, different routing protocol. Likewise, we having the static routing, right? We having the dynamic routing. So in a dynamic routing, we having the multiple flavors. We having the RIP, we having the OSPF, we having the EIGRP, we having the ISIS, right? These are the different dynamic routing protocols, and these all are come under the one of the protocol that is known as the IGP, Interior Gateway Protocol, right? Then after this Interior Gateway Protocol, one another protocol introduced, that is the EGP, which is known as the Exterior Gateway Protocol, right? So this is known as the Exterior Gateway Protocol. So this protocol, when evolved, then BGP come in a picture. So the idea was, let's suppose before BGP, how the network was, communicated to each other. So just think about this diagram, right? This is one of the topology. I'm just going to talk about the very practicals. This is the one of the organizations, and these organizations want to make the communication with this organization. Just forget about this. This is another organization. This is organization A, and this is organization B, right? These are two different companies, right? So if I want to make them communication between the A and B, then the communication is not possible with the EIGRP. The communication is not possible with the static route. The communication is not possible with OSPF. The communication is not possible with ISIS. The answer is yes, it is possible. It's a two different organizations, but still, if I want to make the communication between these two companies, between two different entity, it is absolutely possible. It is absolutely possible. I can make the communication by using the static routing, by using the dynamic routing. Then why we need the BGP? That's the key concept, right? So the problem with this static and dynamic is they having some limitations. And what are those limitations? They have some capability to build a routing, but they not have the flexibility. And if I talk about the flexibility, what kind of the flexibility? So let's understand, you want to do intent-based networking, intent-based routing, right? Means your company want to manipulate some path. Your company want to match some certain conditions, and based on that certain conditions, you want to influence the routing informations, right? Your company want, based on the prefixes, you want to manipulate some kind of the uh, decisions from the any router point of view. So they can do, but they not having the very wide repository in terms of the routing protocols. They having the very lower repository, means they having the limited capabilities, right? So this is the reason, right? Due to the less, flexibility, IGP failed to do the inter-AS communication, right? Means inter-organization communication. One more important, the scalability, right? So if you want to understand what is the scalability problem with this routing protocol, so scalability problem means if you are running the OSPF, right? If you are running the OSPF between these two entity, right? So OSPF is like quite having the very, wide, repository of the database about the routing informations. And if you having the very wide repository of the database for the routing protocols, and you having the very aggressive messages where you have to exchange between these two devices, right? These are two different entity, organization A, organization B. So you have to exchange a lot of parameters, lot of data between these two organizations. It looks very close, but you think about two different entity. One is in India and another is in the US, right? And in between, we having the multiple circuits, multiple ISP providers, right? Multiple ISP providers in between these two organizations. Then how this communication is going to be, how this communication is going to be very scalable throughout this communication by running the OSPF, because there is a high chance, right? If any link goes flap, You again have to rebuild your neighborship. You have to exchange a lot of parameters. Then you have to exchange your database. Similar case is going to happen with the EIGRP as well. So the handling the multiple routing informations means the internet, we having the more than 1 million route right now. We having a 10 lakhs routes right now on the internet, more than that if you go and find the googles. So because of that, routing decisions, we having the very problematic scenario, very problematic scenario where basically we cannot understand, we cannot make the scalable network by using the OSPF. And the most important, if you want to do traffic engineering, if you want to do policy based routing, if you want to do the path redundancy, if you want to like the do the path manipulations, you want to play with the attributes, these feature is not applicable with IGP routing protocols, right? So any of the IGP routing protocols, if you are going to use, they are not going to basically handle the two different company routes or internet based routes or inter-domain based route when you have the requirement to make the communication. So that's why the limitations was there. And by considering these limitations, the protocols has been developed. That is the broader gateway protocol. That is a BGP, right? So BGP especially designed for the just to make the communication between two different entity, two different AS. Means AS means the autonomous system, right? So what is autonomous system? So autonomous system is nothing. Autonomous system is one of the area or one of the system which is managed by the single company. Likewise, your company is the SCL, right? So SCL is the one company, another company is the Wipro, right? Wipro is another company. So these two are the separate entity. So the inside of this separate entity, whatever the communication is going to happen, that is known as the autonomous system, right? That is autonomous system. I can say 10. That's belong to the Wipro. Autonomous system. I can say 20. That's belong to the SCL. So autonomous system is something that is basically it's belong to one organization. Similarly, if you want to make the communication with the your company to any ISP, right? Let's think about this is your company, which is might be the SCL again, and you want to make the communication with the ISP that is Airtel, right, in India. So Airtel having their own autonomous system. This Airtel is basically going to be, manage their own infrastructure by referring this autonomous system. This SCL is going to manage their own infrastructure by referring the autonomous system. Means inside this company, whatever the communication is going to be happen, they refer one autonomous system, and that is going to communicate to the another autonomous system if you want to make the any communication, right? So this is the autonomous system. So this is going to play a very vital role throughout this particular all communication, right? So BGP is a border gateway protocol that basically standardized as a exterior gateway routing protocol, and that having a responsibility to exchange the routing and reachability information between two different AS system, means two different autonomous system, right? Over the internet within the organizations, or might be the over the two internet providers circuits. This could be anything, right? So autonomous system is nothing. Autonomous system is a collection of the network, means IP network device connectivity. Router that can be, switches, L3 switches, might be the firewalls. They belong to the single entity, single organizations. So autonomous system is nothing. Autonomous system is simply, we can say, it's a collection of the multiple routers, switches, firewalls who are capable to run the BGP within the organizations. That's the autonomous system, right? So key aspect why BGP is very essential for us. So we just have to understand this key aspect as well, right? So if I talk about the key aspect about the BGP, so let me write it here. So we're having the multiple flavors. So if I want to do the inter AS routing, right? So in that case, the most important and most durable protocols is the BGP. If you want to use the path vector, right? So BGP is also known as the path vector routing protocols, right? So if you want to use the path vector protocols, so you just have to use the BGP because the BGP uses the path vector. You just want to use the policy based routing. So policy based routing, you can use other routing protocol as well, but you can use the BGP as a best policy based routing because they also use the attributes, right? So these attributes are basically very helpful to manipulate the path, and they are going to scale your network, right? So that is also going to give the scalability, right? Very important. And this was the main key things, right, where we can think about the this BGP is a very popular, right? Let me put it here. So scalability is there. And now traffic engineering. So what is traffic engineering? So if you talk about traffic engineering, that is something, if you are using the MPBGP, then this traffic engineering come in a picture, right? And they having a capability, they having a real type. If you want to manipulate a lot of parameters based on the attribute, we having the list of the attribute in the BGP, and if you really want to, manipulate the path, then it is going to be used, right? So traffic engineering, that is a part of the MPLS, right? And sixth one, you can do the path manipulation, right? So that is going to happen, path manipulations. It is also capability the quick fault tolerance. So if you want to have the quick, fault redundancy, fault tolerance, you can just get it very quickly. You can get it, which is not possible with the any other IGP protocol, right? And also it is give the very reliable, or we can say internet or the intranet, even the MPLS circuit stability, right? So these all the key features we have, many more features we have, but these are the key features we have which we should know, right? And these are the key BGP fundamental, right? So if we are using the BGP, right? So BGP basically going to give lot of flexibility to us, and by using that lot of flexibility, we can do the lot of manipulation in terms of the routing, right? So there is multiple flavor of the BGP. Means if I'm talking about the multiple, they having the one flavor known as the eBGP, right? And one is the iBGP, right? So what is the eBGP and what is the iBGP? So if I talk about the eBGP, so let's say suppose you want to run a BGP between two organizations. Means you having the one of the company is the SCL and one company is the Wipro. These are the two different company. So one is the this company and one is the this company. And you want to make the connectivity over these two company, then this company having the AS number, let's suppose AS number 10, just an example, and AS number we can say 20. So when we want to make the connectivity between these two company, which is completely two different entity, then we have to use the eBGP. That is known as the or we can say external BGP, right? So exterior or external BGP is the same thing, right? So means we are building the communication between two different entity, right? So eBGP. But let's say suppose this is your one organization SCL, right? This is the one of the SCL organization, and this SCL having the multiple routers within the company. Might be one is the one in the might be the Chennai, right? One is the Bangalore, one is the UK, one is the US, but they are the same organizations. They can connect within the multiple ISP, but this is the R1, this is the R2, and this is the R3, and this is the R4. And if they want to make the BGP connection between each other, right? So all are known as the iBGP, which is known as the internal BGP, right? So now we have the better understanding about the eBGP and iBGP. So we have to go slowly deeper and deeper. But yes, these are the fundamental which we should know, right? So if someone is going to ask, right, why we need the BGP? So you know that BGP is something, the main purpose to exchange the routing updates. But at the same time, your IGP is also doing. So why we need the BGP? So BGP is something which having the more reliability, more features, more scalability They having the capability to do the manipulations. They having a capability to carry the very large routing database in the quicker time of period, where IGP is going to fail, right? Where the IGP scalability is going to be very challenging, right? So that's why the main purpose of the BGP to exchange the routing updates, likewise the routing protocols, the BGP can be classified into the IBGP and the eBGP. That is always going to recommended to run when we having the inter-AS communication. Inter-AS means we having a two organization, they want to build the communication, then they are mandatory, that is going to be required the BGP communication, right? So now if we talk about, right, the path attributes, we having a lot of path attributes, right, the BGP. So we having the path attributes, let me just write a little bit here. So we having the path attributes. So just I'm explaining, we having the well-known mandatory, right? We having the well-known discretionary, right? We having the optional, transitive, and then we having the optional non-transitive, right? Transitive. Right. So these are the path attributes. So first we have to understand what is a path attributes. So path attribute is nothing, right? Let's say suppose you have to influence something. Let's suppose these are the one router. This is the R1, right? This R1 connected with the R2, right? And this R3 also connected with the R1. This is the R4. This is my another router. This is the R6. We are running the BGP. Let's suppose we are running the eBGP here because they all belong to different organization. So this is again eBGP. Sorry, eBGP. This is the eBGP. So let's suppose this is the one of the network. Let's suppose this is the 10.10.10.10.0/24. Wanted to connect on this network, that is the 192.168.10.0/24. Then how this communication is going to be happen, right? And how this path attribute is going to come in a picture. So I'll do the configuration step by step in the later stage, but I'm just explaining a little bit so you guys can understand about the basic fundamentals. So path attribute is something where we want to influence the normal routing decision. So what is the normal routing decision? So let me just write here, normal routing decision. Right. So what is the normal routing decision? So let's suppose this is the one of the network want to reach on this network. So the first packet will start from this LAN network and it is going to land on this router. Once this packet is going to land on this router, so router is going to check the routing table. So there is two kind of table. One is the rib table and one is the fib table. So what is the rib table and what is the fib table? So rib table is known as the routing information base. Routing information base in the router, and the fib table is known as the forwarding information base, right? So this is the fib table, and these are the two tables, and third table we having, that is a routing table. Apart from these two, we having a third table, that is a fib routing tables, right? So router having a three kind of table, but technically rib is something, if someone is going to ask what is a rib, so rib is something, routing information base means they having the repository, means the collection of all possible routes. Means what is the all possible route? Let's say suppose I'm giving the another example. What is a rib? Many people understand the definition, but they don't understand the concept behind it. So let's suppose this route I'm learning on this router. This route 192 I'm running on this router. So one copy I can receive on this link, one copy I can receive on this link, one copy I receive on this link. So this router having the RIB table, just suppose this is the RIB table. So R1 saying if I want to go in this network, right, I have three next hop entry. I have three next hop entry. Means 192.168.10.0 can via the R3, can via the R2, can via the R4. This one having the, let's suppose AD is 10, this one having the AD 20, this one having the AD 30. So I have three routing table in my routing RIB. I have three routing table in my routing RIB. But which one is going to be installed? Which one is going to be installed in the my routing table? So the answer is which having the better AD value or longer prefix match. There is a criteria. So AD value, longer prefix match, and different depend if you are running the same same routing protocol, then we having the OSPF having a different way of the selection, BGP having a different way of the selection, EIGRP having a different way of selection. But just think about it, we are talking about just AD value. So this all three routes are going to install in the RIB table. But out of three route, one route is going to install in the FIB table. Which route? Which having the lower AD value means this is going to install 192.168.10.0 via R3, which having the AD is 10. So this route is just going to install in the FIB table. All three possible route is available in the RIB table, but best route is going to install in the FIB table. And this best route is always going to populate in the routing table. Okay, so I hope you guys understand the concept. So RIB is something collection of the all possible route. FIB is something collection is the only best route. And let's suppose this route stop learning, then which route is going to come in a picture again? The FIB, that is a 21. If this also goes down, then 31, and then this is going to be updated in the routing table. So the routing table is going to be checked, and this routing table saying if you want to go in this network, you should follow this path. So this is saying as per the normal routing decision, if you want to go on this network, you just follow this path. So let me use some different pen. So you just go this way and this way. This is normal routing decisions. Means normal routing decisions. If your any routers want to reach to any destination, they will just check the routing table, and based on the routing table, based on the destination prefix, it will check the next stop, and after the next stop, next stop router will forward send packet to the destination. But by the help of this path attributes, by the help of this path attributes, you having a luxury. You having a luxury, you can manipulate the path. And how the path is going to manipulate it? The path is going to manipulate it based on your intent, based on your configuration. Means even I'm getting the best route, even I'm getting the best route from this link, but if I want to manipulate, I want to send that outbound traffic via this link. Is it possible? Yes, I can do that. I want to prefer not this route, I want to prefer this route. Is it possible? Yes, I can. So even my router, as per the normal routing decision, it's coming as a best route from this link, but I want to send a traffic via this path. It is possible. So this is the path attributes. We having the well-known mandatory, we having the well-known dictionary, we having the optional transitive, and so we have to deep dive. We have to do the deep dive. What is a well-known mandatory? What is a well-known discretionary? And what is a optional transitive and non-transitive? Right. So this is also next session, advanced session, where we are going to discuss and cover these all the steps, right? But basic fundamental, these are the path attribute. Also, one of the most important, this BGP is completely loop free, right? Why loop free? Because whenever you talk about that, any communication, let's suppose we having a scenario. This is the R1 and this is the R2, right? This is the R1 and this is the R3. So as we know that BGP use the AS number. So let's suppose this one having the AS 10, this having 20, and this having a 10, right? So what is a loop? Loop means if you are getting the same route somewhere else, which you are originating, right? Might be I'm sending something and I'm receiving the same route from somewhere else. And if I'm going to install that route in my routing table, so it is going to make a loop. You can think about this way. This R1 and this R2 and this R3. They are connected in this way, right? And this one having, let's suppose 10 AS, this one having a 20, this one having a 30 A. I just advertise the route 1.1.1.1. It is going to send this, it is going to send this, it is going to send this. You can see. So you can see, so this is going to make a loop. It is going to make a loop. So this is the very unique protocol. Even most of the all of the routing protocol having the loop prevention mechanism, but this is the unique protocol. Let's suppose it is originating something route with on AS, and if the same route is going to receive by the on AS, because whenever any route is going to travel over the internet on the BGP, along with the route 1.1.1, they also carry the AS information. So somehow if it is going to receive the on AS number, it is going to discard it. So that is not going to make any loop. So this is why loop free routing protocols, we can say that, right? So the AS information is always going to be used, and that is going to be help to prevent the right routing. So we already know we having internal BGP, we having the external BGP. We know that how the rev and fib is going to play a role to just make the routing decisions, and based on the path attributes, we can just manipulate the, you know, all kind of the routing decisions. And same thing, we are going to do all testing. Let me just open some ebooks. So someone is planning to go with the CCNP NRC. So you can understand what level of the content we have in terms of the CCNP NRC. So let me show you something. So let me just go there. So here you can see we having advanced routing, and if we talk about the BGP, right? So first is the BGP fundamentals. So BGP fundamentals, BGP basic configuration. So we'll do step by step all the configuration, understanding the BGP session type and behavior, multiple BGP for the IPv6. We having a quiz as well, right? And BGP fundamentals. If you read the BGP fundamental, why explain? So from the perspective of the BGP as an autonomous system is a collection of the routes under the single organization control. So you can see the same thing what I discussed, right? But they are in a more sophisticated way. They are very summarized way, and it is used one or more interior gateway routing protocol and a common metric to route packet within the AS. If the multiple IGP or a metric are used within the AS must appear the consistent with the external AS routing policy. So see, these are the little bit confusing, right? So unless you not having the very good knowledge, then you cannot understand what it is talking, right? What the meaning of the BGP fundamental definition written in the official Cisco press book. But what I'm trying to say, see, any decisions, even I'm going to make the BGP routing protocol between these three routers, R2, R, R2 and R3. Someone say me, just make the BGP session between these two routers. Just make the eBGP. I'm not going to make the BGP session between R1 and R2. R1 to R2, no BGP, right? R2 to R3, no BGP. Understand what I'm trying to explain these definitions, okay? So you can understand it very easily. So the question is, you have to make the BGP between R1 to R3. First question, is it possible? First question, is it possible? Just ask yourself, is it possible? Can I make this BGP between directly R1 to R3? The answer is yes. It is possible. We can do that. Why? Because the BGP having the one conditions. Whatever addresses I'm going to use, let's suppose I'm going to use the addresses 1.1.1.1 here as a loopback /32, and one address I'm going to use here 2.2.2.2/32 here. These are two loopback address, right? So the condition is only you have the basic IP reachability between these two loopback address, basic IPv4 or IPv6. If you are using the IPv6 addressing, reachability between these two address. That's all. So how the reachability is going to form? How the reachability is going to form? Because BGP only going to build if you're having the reachability. Then your IGP come in a picture. Interior gateway protocol is coming in a picture. That's why they're talking about this, right? you have to use the IGP. You might be seeing the multiple IGP routing protocol running between. So you can use between these two as a static route. You can use between these two a static route, and you can just point the static route pointing to R2 and then R2 to R3 to R2 back forward and reverse route, or you can use the OSPF, right? I can use the OSPF, and then I can advertise this network OSPF. This is going to learn here and further from here to here. Similarly, reverse it. So once I have the reachability, then I can go and I can create the, like I have to go in this command prompt router BGP, and then I have to write the neighbor address 1.1.1.1, and remote is I can just write whatever 20, and just that's all for the simple communication. This is the R1 side, and R2 side you just have to go and again have to route router BGP 20, and then you just have to go here neighbor 2.2.2.2, remote is right 10, just two commands. But here, because we are making the loopback address, right, as a BGP, so you just have to use a special command neighbor 1.1.1 and update loopback source. We can just make that the this one. So neighbor, sorry, in R1 is 2.2.2. Sorry, my bad, 2.2.2.2, and here is the R1 1.1.1.1. So you just have to use the update loopback source to just make the reachability, so that your loopback to loopback connectivity is going to happen. So there is again logic why we use the loopback, why cannot we use the directly connected interface. So I'll explain in the later stage, but yes, this is how it is going to happen. So this is the basic fundamentals. So that's why again you read this from the perspective of the BGP autonomous system, that we know that is a collection of the routers under the single organization control, and it use one or more interior gateway protocol, IGP they are talking. It use, why it use, just make the basic IPv4 or IPv6 reachability. Common metric to the route packet within the AS, right? And so common metric, that is the route packet within the AS. If you want to just make the routing reachability within the AS, then it is going to require. This is all talking, and then they are talking about the autonomous system, right? So we already discussed what is the autonomous system. So autonomous system is something any organizations, right? If and this autonomous system, again, two type of autonomous system. One is the private autonomous system, one is the public autonomous system. So if you talk about the private autonomous system, right? So private you can use, you can use private autonomous system, and you can use the public autonomous system. So might be having the range here. So you can say two block of the private ASs are available for the any organization to use, as long as these are never exchanged publicly on the internet. AS number this, and these are the private. See, so this is a range for the private. So if you are going to use any AS number for your company, that is starting from 64512 to 65535. These are the private AS number, private AS number. And after that, if you go for the extended range, you can find this is the again extended range for this all, right? But before and after this, all AS are belong to the public AS number. So you cannot take this public AS number by on. You cannot get this public AS number on, right? So to get the public AS number, you just have to connect with the INA, right? Who just going to assign the public AS number, right? To just different organizations. So your organization must have to connect. Why you require the public AS number? So there is again concept. Why the private AS number? Why the public AS number? So see, let's suppose this is your organization, right? This is your organization. This is the SCL organization. This SCL having the multiple routers, right? These all routers might be they connected in this way, right? They are running the IBGP. So R1, R2, R3, R4, and R5. They all are the connected. So if I'm using any AS number that like a 64512, this is a private. So I can talk to my internal network. But let's say suppose I have to talk with the internet. Then I have to make the BGP with the internet. But here, once you go on the internet, you require the public IP and public AS number, right? So these two things is going to be required. So you require the public IP and you require the public AS number. Then only you can make the communication with your public network. Understand? So this is how it is going to be happen. So basically, inside of the network, we can stay with the private one, but the moment we have to talk to the out of the my internal network, I have to go on the internet, then public AS number is going to required and public IP is going to required. And who is going to provide? That is going to Internet Assigning Authority, INA. This is going to give the public AS number, right? So you can see here they are talking about an organization required the connectivity to internet must obtain the AS number. They are talking AS number were originally initially 2 bytes when it was invented, and that was the range AS number possible. Due to exhaust of this range, RFC 4893 extended the field 4 byte, and then this range is available, right? You can see even you can use this AS number as well, right? So but these are the two private, and these are the private numbers where you use the private. Rest all are to the public, but you just have to use the public AS number. So next we discuss about the BGP fundamental. We discuss about two type of the BGP sessions. We have the internal BGP. We know why we need the internal BGP because I explained if I want to use the BGP within my organization, right? That with the private AS number, that is my internal BGP. If I want to go for the external BGP, means between two different organization for the public connectivity, even for the private, both case I require the eBGP. But if I'm going to use the public, then in that case, I require the public AS number, public IP address. If I'm going to use the MPLS, then private AS number and private IP address. That is, but two different AS number is going to be definitely there to just make that connectivity. So these are the eBGP and iBGP connectivity. We have the path attributes, well-known mandatory, well-known discretionary, optional transit, optional non-transit, loop prevention. So we discuss about, right? So in next session, probably we'll deep dive because this is a very deep level of the knowledge is going to happen in this BGP. So I'm not going to cover these all. So what I'll do in the next session, we'll configure this small lab, or let me show you how this BGP is going to like configure quickly. So just to get the flavor, right? So I'm just going to show that demonstrate this topology, how this is going to happen. So if someone going to ask to just configure the BGP, then how quickly you can configure it. So, and how this two loopback based BGP is going to be formed. I can make the directly connected BGP as well, but that we can understand in the two BGP based on the loopback address. So why it is very important. I'll show some basic command as well, so you guys can understand. So let me show you here. So quickly, let me configure it. Okay, come on, come on, come on. So here you can see. So I'll go here config T and host name, that is R1, and I'll go on the interface gig 0 by 0, right? And I'll assign the IP address 1200001, 255, 255, 255, 252, right? No shit, and do right. Similarly, I'll go in the R2 having this this router having, let me go here, host name R2, interface gig 0 by 0, sorry, IP address 12.0.0.2, 255, 255, 255, 252, no shit, right? We just have to configure the loopback as well. Loopback to IP address 2.2.2.2, 255, 255, 255, 255. So we just created. So you can see we created one loopback, one IP address. Let me configure loopback on this router as well. So interface loopback one, IP address 1.1.1.1, 255, 255, 255, 255. Right. So something is not good. One is extra. Right. So if I want to make the direct BGP between these two IP, it is possible I can make. So let me make this BGP between two neighbors, right? How it is going to happen? So if I am trying to ping the first condition, the neighbor which you want to make the BGP neighbor, that should be reachable. If it is not reachable, you cannot make the BGP connection. So if I am trying to make the BGP between these two routers, so my R1 want to make the BGP neighbor with this R2. So just think about R1 having the AS number 10, this one having a 20. We are building the eBGP. So I just want to make the BGP between these directly connected interface. So these directly connected interface should be reachable, which is, we can see it is reachable. R1 to R2 to R1, I can also reach that. Let me show you. So now I can build the BGP. If it is not reachable, I cannot build the BGP connection, right? So how it is going to happen? So I can go in the configuration and router BGP. I'll use my on AS number. So one, the router should have their on AS number, and the another side router having their on AS number. So 10 is this AS number, 20 is this AS number. Just for without AS, you cannot configure this BGP. Let me show you again. So we go in the configuration. Let me show you. So router BGP, and you must have to define the AS number. Without AS number, you cannot do it. This is the extended 4 byte, and this is a 2 byte. So I can use the 10 AS number here. And neighbor, I can define the neighbor IP. What is my neighbor IP? 10.10. Sorry, 12.12.2. So 12.0.0.2, and remote AS I have to give 20. I should know this remote AS. So this all information you have to gather before building the BGP configuration. So my BGP configuration is done from the one router point of view. Section BGP, just 2-line command. So I just build the BGP configuration on the R1. But what about the R2? So if I running the command show IP BGP summary, there is no BGP. You can see the BGP session is showing down. So if I go on the R2, configure T, router BGP, this BGP having the S number 20, then I'll configure the neighbor. Neighbor is .1 because I'm making the connectivity with the R1, and then R1 AS number is 10. So I'll use this 10, and that's it. The moment I'll do that, after some time you will see that BGP is showing up to me. You can see here. So earlier this BGP was down, but if I run this command again, you will see that the neighbor, and this is the AS number, this is the message receive, message send, and this is the uptime. So my BGP is set. My two point-to-point BGP, neighbor to neighbor BGP is set. But if I ping R1 to R2, it is not going to pingable. Loopback to loopback is not reachable because this has neighbor advertised in the BGP. So that network you want to reach from the one neighbor to another neighbor, you just have to also advertise in the BGP. I can make the next session as a loopback BGP connection via the IGP reachability, but now I'm just going to advertise how I can advertise my networks which I want to make the reachability from the R1 to the R2 via the BGP. So you just have to go in the network 1.1.1 and mask. You just have to put the loopback mask eject. The moment you will do this command, right? Right now you can see in this place show IP BGP summary. Earlier it was not showing any route, but now it start receiving route. You can see. So you will start getting a route of the one subnet via the BGP. See, this is the B route. Similarly, if I go on the R2 BGP configuration, so run section BGP, and I'll do the advertisement of the R2 loopback. So router BGP AS number is 20, and I'll just go in the 2.2.2.2 and mask 255, 255, 255, 255. Then it is going to be available show IP route. It is going to show the two route also. So now if you are going to ping from R1 to R2, it is going to reachable because you having the routing table in the routing. See, you're able to reach even with the source loopback 1, it is going to reachable. Even from here, you are trying to reach ping 1.1.1, it is reachable, right? With the source loopback 2, it is reachable. So this is a basic BGP configuration, right? So I just explained how the BGP is going to build over these two neighbor. Next, I'll explain how the BGP is going to build over the loopback. So for loopback, first we have to make the IGP reachability. Means via the static route or any dynamic routing protocol I have to run. That is the IGP routing protocol. I can run the OSPF in between two router and advertise this two network in this, or I can use the static route I can use the EIGRP, I can run the RIP, either of the protocol I can run. And then I can just make the IGP reachability loopback 1 to loopback 2. And then I can form the BGP connections. And then in that BGP connection, when I'm going to form the loopback, I have to use some special commands as well. And why it is important, I'll explain. So we'll see these all steps in the